Something huge is being constructed in a remote corner of Japan. It's costing over $500 million and is the biggest of its kind in the world. It's been in development for over 20 years. It's over 80 meters high and nearly 70 meters wide. But you're not going to spot it very easily because this enormous structure is hidden deep in the landscape, quite literally. And when it's finished, it'll look something like this. So, just a couple of simple questions. What is it? And why are they hollowing out a mountain to build it? Okay, now before we go any further with this video, we're going to need to do a quick science lesson. So notebooks open and pay attention at the back. Our universe is made up of tiny subatomic particles such as quarks, bosons, and smallest of them all, neutrinos. Neutrinos act in strange ways. They fly through space, but don't interact with any other matter. Billions of them move through your body all the time without having any effect on you at all. Now, if we understood how that happened, it could fundamentally change how we think about the universe. But as you'd probably guess, with the smallest particles in the universe, they're quite hard to spot. One way of detecting them is by smashing larger particles together at high speeds and recording the reaction. That's what's happening over at the Large Hadron Collider in CERN. Another way to observe them is just by listening, which is about as easy as it sounds. Ideally, you need somewhere remote, quiet, and very peaceful. Fortunately, Japan is pretty good at that. This is Kamioka, a small town in the Japanese Alps, and this is Mount Nijugo, home to the Hyper-Kamiokande. It's a $600 million science experiment led by the University of Tokyo and supported by researchers from 21 countries. When complete, it'll be the largest neutrino observatory in the world, and a breathtaking feat for Japan's construction industry. But as incredible as it is, it's actually not the first of its kind. This is going to be the third Kamiokande in this region. This part of Japan is known for its zinc mining industry, and it was the expertise of a local mining company which, back in 1983, helped construct the first Kamioka nuclear decay experiment, or Kamiokande for short. The success of that gave rise to the Super Kamiokande in 1996, and the Hyper-Kamiokande under construction today. It consists of a huge cylinder carved into mountain rock and accessed by an approach tunnel at the top and a secondary tunnel at the base. It's 88 metres high and 69 metres wide. That's big enough to fit an entire Boeing 747 standing on its end. Now, don't worry, we're going to get on to how it works later, but first off, how do you build something like this in the middle of a mountain? Well, plans for the Hyper-Kamiokande go back to 1999. Then, after more than 2 decades of development, work began in May 2021 on the access tunnel. Using a drill and blast technique, it took just 9 months to excavate the 2-kilometre approach tunnel, which was then sprayed with concrete to create a smoother and more stable surface. This approach tunnel leads to the centre of what's going to become the roof of the observatory. Now, as the observatory sits 681 metres below the mountain peak, a dome structure was created, which was then reinforced by a steel truss to hold the enormous weight of all the rock above it. That was completed in October 2023, and now the team have begun the next stage of the project, blasting down through 71 metres of rock to create the enormous cavern the observatory is going to sit in. This rock is hard work for the construction crews, but it's what makes this site perfect for spotting neutrinos. The density of the rock is the equivalent of this observatory sitting 1.7 kilometers below the surface of the ocean. That's no problem for the neutrinos, which can pass through entire planets with ease, but it provides excellent insulation from cosmic rays and other background radiation which could ruin this experiment. Drilling's due to complete in 2025, but at that point there's still going to be a long way to go before it can detect a single subatomic particle. First, the inside of the cavern is going to be lined with 2 layers of concrete and, crucially, a waterproof layer. That's because this cavern is set to become the largest tank of water in the world. Once fully watertight, 260 million litres of water are going to be pumped into this enormous cavern. That's nearly 4.5 times larger than the world's largest aquarium over at SeaWorld Abu Dhabi. It's going to be flooded from the water table in the mountain and will take about half a year to fill. But as clean as this water is, it undergoes further treatment with UV light and other means to create water so pure it's capable of dissolving metal. Now, the massive tank of water creates the perfect conditions to spot neutrinos in. Time for a bit more science. When neutrinos pass through the tank, occasionally they'll collide with electrons, giving off a weak glow known as Cherenkov radiation. And that is what this whole thing is being constructed to observe. Tiny glimmers of light in a giant cavern full of water. The Hyper-Kamiyokande isn't complete yet, but to get an idea of how it will look, here's its smaller sibling, the Super-Kamiyokande, which is less than half the size. Here, the cavern's been drained because engineers are performing maintenance on these photodetectors, the thousands of light sensors that together act as a giant camera. The ones in Super-Kamiyokande are so sensitive that a single sensor could detect the light of a torch being used on the moon. Together, they act as a giant camera that picks out the faint traces of Cherenkov radiation created by reacting electrons. 40,000 of these are being manufactured for the Hyper-Kamiyokande, each one almost twice as sensitive as their predecessors, and specially designed to withstand the enormous weight of 260,000 tons of water. Construction is expected to fully complete in 2026, and the Hyper-Kamiyokande should start detecting neutrinos and performing other experiments by 2027. Now, as cool as all of this is, you might be forgiven for thinking, so what? After all, what has particle physics ever done for me?
What have the Romans ever done for us?
Well, for a starter, if you've ever had a medical scan or had a tumour diagnosed, you have particle physics to thank for that, as well as treatments for everything from cancer to AIDS. It's led to greater understanding of fluid dynamics, which helps in the construction of long-distance pipelines and gives us more accurate weather forecasts. And let's not forget that it was for a group of particle physicists that Tim Berners-Lee developed a new system for quickly and efficiently sharing information. A system which is enabling you to watch this video right now. It's probably pretty fair to say that this is one science experiment that's definitely going to live up to the hype.